Hello everyone, I'm Sanjay Vasu and I'll be showing you some practice questions for the IGCSE Mathematics about the topic congruence. Let's start. Question 1. Show that these two triangles are congruent. This is a straightforward question since we know two angles and we know one side for both of the triangles. Alright, we can find the third angle for both of these triangles. So for triangle ABC, the angle ABC, which is unknown for now, we can find that by using 180 minus 95 minus 28, and that turns out to be 57 degrees. And why is it 57? Because angles in a triangle add up to 180. So we're subtracting the first two angles from 180 to get the third one. Now, same thing for DEF. So angle DFE is going to be 180 minus 57 minus 95. That's simply going to be 28 degrees. And therefore, we got this as well. Now we can see that there's a side and there's two angles right next to it which are both the same for both triangles. So due to the ASA property of congruence, triangle ABC and triangle DEF are congruent. We can see that BC is equal to DF, some side lengths are equal, and then angle ABC is equal to angle EDF, and angle ACB equals angle DFE. And because of these three, we have ASA property, which is angle, side, angle. If these three are equal, they're congruent. So that's our answer. Let's go to question 2. A, B, and C are points on a circle with center O with radius 5 centimeters. In other words, OC is 5 centimeters, OA is 5 centimeters, and OB is 5 centimeters as well. AC is the diameter of the circle, and point D lies in AC right there. EF is a tangent to the circle at the point C. DE is equal to 10 centimeters as given. A. Show that the triangle ABC is congruent to triangle DCE. Give a geometrical reason for each statement you make. Now the first thing is, we can say that AC is equal to DE. How? We know that AC is a diameter, which is 2 times the radius, which is 2 times 5, 10 centimeters. And that's equal to DE. And the geometrical reason for this is radius times 2 is equal to diameter. This is the simpler one. Now, for the angles. You have a 38 here and you have a 52 here. The first thing we can relate is that when we add the two angles, we get 90 degrees. So there's got to be something about right angles in this question. At least usually there would be. And in this case, there is. We can see that angle ABC is a right angle. And angle ACE is a right angle. Why? Need to write that as well. So angle ABC equals 90 degrees due to the fact that angle in a semicircle is 90 degrees. Or you can write angle subtended by the diameter on a circle is 90 degrees. Subtended means you have a diameter and you have two lines extending from the diameter and they both touch a point on the circle. In other words, these two are chords extending from diameter, and this is always 90 degrees no matter where you place it. There's also 90 here. Now, why is angle ACE 90 degrees? Angle ACE equals 90 degrees because the tangent and radius meet at 90 degrees. We have a tangent, which is FE or EF, and radius, which is OC. And they meet at C, which forms a right angle on both sides. And in this case, we care about this angle, which is 90. So just mark what we know, 90, 90, and AC is 10 centimeters. Now, we need to find one more angle. And this is not the most complicated one, since we can see easily that angle ODE or angle CDE is 38 degrees. Since angles in a triangle sum up to 180 degrees. This is 38 because 180 minus 52 times 90, which is 38. We get that over there. So we can write therefore angle CDE equals 38 degrees, and we can also write why this angle is 38 degrees. The reason is the alternate segment theorem. We have an angle formed by a chord and a tangent which meet at a point, in this case C. So if we draw a line from that point anywhere on the circle and draw a line from this point where the chord touches the circle to that same point over here, which is in this case A, this angle formed between the second chord and this one here will always be equal to the one over here. So this is the chord which splits the circle into two segments, as we can see, A and B, let's say. So B is the minor segment, and the major segment has the angle A in it, and the major segment has this angle in it. So that's why we call it the alternate segment theorem. It's in the opposite segment as where this angle is, since this angle is inside this segment technically. So it's called the alternate segment theorem, and therefore we get angle BAC equals 38 degrees due to alternate segment theorem. Now, we have a lot of information. And of course, we have one more piece of information here, that this is 52 degrees, since, once again, angles in triangle sum to 180 degrees, of course. Or we can also write that because tangent and radius meet at 90 degrees, and this is 38, so this is 90 minus 38, which is 52. Both are correct. We have to write at least one reason though. So now, using the same property we used last question, we have one side and we have two angles, right? One side and two angles. Let's just write those down. Angle BAC equals angle CDE, and they both are equal to 38 degrees. And then angle BCA equals angle CED, which is equal to 52 degrees. And the last one is AC is equal to ED. Let me just write this clearer. AC is equal to ED, which is equal to 10 centimeters. And let me just move this up a little bit to get some space. There we go. So due to ASA property, triangle ABC is congruent to triangle DCE. That is going to be our answer. We're not done yet. We have a B part for the same question. Calculate the length AD. AD is this small line segment there, and it's not really a side length of any triangle. So how are we supposed to find that? Well, let's see some line extensions. So AC is an extension of AD, and this extension is known to us in length, which is 10 centimeters. That's the diameter of the circle. And we can find this side length using the angles and the side hypotenuse here of this right angle triangle. So we have CD, which we need to find, only then we can find AD. So we can use any trigonometric property for this. We can use either the sine or the cosine to find the length CD. So I'm going to be using the sine. So sine of an angle, in this case 52 degrees, is equal to opposite divided by hypotenuse. So sine x equals opposite by hypotenuse, and in this case sine 52 is equal to the opposite, which is CD by the hypotenuse DE, or 10 centimeters. So CD by 10 centimeters. That means CD is going to be, let's go calculate out. So let's do sine 52. Remember that the calculator is in degree mode, only then you'll get this. Otherwise, if you're getting a different answer, check the mode of your calculator. You might be in radian mode, which is not what we need for the Cambridge IGCSE exam. So we're using sine 52 degrees multiplied by 10 to get 7.88 centimeters. This is quite an accurate estimation, even though it's just 3 significant, because the next few digits are 0, 1, 0, so it's not a huge difference. Now 80 is simply going to be, as we talked before, AC minus CD, which is 10 minus this new value which you have, or 7.88. And let's just do that. 10 minus 7.88, 2.12 centimeters, 2 3 significant figures. And that's our final answer. With this, I come to the end of the video. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.